Hello, I'm Alessandro. I'm from the Council for Agricultural Research and Economics, Research Center for Forestry and Wood. So this presentation is a bit technical because we wanted to experiment a new solution given a DJI UAV platform. We assembled a micrometeorological station based on Arduino technology with many sensors, mainly to capture the gases concentrations. We used also here a pyranometer because we wanted also to gather data about the surface reflectance, and the thermal camera and the red edge camera. So a lot of data with only one flight. All this information we wanted to calibrate a soil plant atmosphere model that needs a very lot of inputs. So some are very economic sensors, like the LiDAR one. It is a micro LiDAR. It costs about 100 euros, so it's very low price. And it gives you the distance of the UAV from the vegetation. It captures this distance from about 30 meters. We experimented during the first flight. And it's a very fast data that you can get from the UAV flight, because we need to do many flights to do this calibration. In the payload here we have on the gimbal a multispectral camera. The red edge is a very nice camera that personally I found gives a very little problem here when you have to orthomosaic all the images, because it acquires symmetry on the entire image. It acquires on 5 bands, and we have very strict intervals. And with this we can catch little differences between the species, especially along the red edge interval of the reflectance curve. On the payload here we have the OptiSpy 450 that we saw before in the presentation before. It's a very nice camera, and we use it to get the temperature of the tree crowns, because it's a physiological parameter that plays a lot in how the vegetation exchanges gases with the atmosphere. For the UAV flight planning, we use a proprietary software, UGHS, that it's very simple in its use. After you have done a setup with the properties of all the sensor cameras, so field of view and resolution and so on. So once you have found you are to study, just you draw a rectangle, and it gives you fastly the flight necessary to catch the orthomosaic at those resolutions. So for the flight planning, obviously in Italy, as in other European countries, there are regulations, and they are very strict regulations, especially around our research center in Rome. Normally, you can fly about at a height of 150 meters above ground level, with a maximum horizontal distance of 500. You have to make the flight here in visual line of sight and with full control of the UAV. This is a problem because during the flight, at a distance of about 200, 300 meters from the controller, you lose the control totally of the vehicle. So if you want to fly safely, really, with every control under your hand, you have to keep a distance of about 200 meters, which is the distance that you have to keep inside aeroportal pertinence areas, and about a height of 70 meters. It may seem a short distance from ground, but at 70 meters you almost lose sight of the UAV. And of course, inside the aeroportal areas, the flight is totally forbidden, so you need a special authorization and special permission in this case. The operational limit that we found most relevant in our case is that you have to keep a distance of 150 meters from urban areas, including roads, and 50 meters from people. Yeah, the first idea beyond the UAV experiment was to go near the viability, near a main road, and study the gas emissions and how the vegetation interacts with this emission along some transects, but we couldn't do it for low restriction in this case. Just to give you a touch of fear that I had once they showed me this map. This is an aeronautical cartography that you have to consult before the flight, because it shows the restricted areas and also the aeroportal areas. And as you can see, the zone of room is totally covered by these areas. I was so scared that I asked an aeronautical commander, a person of very much experience, if I could fly in a point there around Rome. He stood there about 10 minutes, 15 minutes to consult this map with Google Earth and so on. But he told me at lastly that I could fly in that zone, that it was okay for me. I double-checked it after, because I double-checked everything, and I couldn't fly in that zone. So the penalty to fly in a restricted zone is 6 months of reclusion, up to. So it's a very serious thing in this case. During the flight, before we saw that we have many passages from the same areas. From all these passages, you catch many photos of the multispectral camera and of the thermal camera. So you see each feature on the ground from multiple point of views. This is exploited by an algorithm that is called structure from motion to build a 3D point cloud. So we have a photogrammetric cloud with each point with the 3 coordinates x, y, and z of each point. And this is the base to process the data set, the photogrammetric data set, for to produce orthomosaic or digital surface models and so on. In our case, we wanted to study urban vegetation or peri-urban vegetation. which is not so close as in the case of forest. This is relevant because, as from the study of Lisen et al., you can see that the photogrammetric point cloud here doesn't get below the surface of the canopies. So we don't have the ground reference to take many aids, unless you have many open spaces, as in our case. After the other processing of the 3D point cloud, you can get ortho mosaics that are really beautiful in the case of the Micasens. This is a urban forest, not too much far from Rome. And here we could detect the many differences there are in these small areas. There are about 10 species here, are conifers. And we use it to a segmentation to get the crown of each tree, because it's the data that we need very much in the model. So the purpose here is doublefold. We have to analyze the vegetation structure that we do with the thermal and the multispectral camera, and the gases concentrations for the model. Here are some sensors, and we really spend a lot of time with this for calibration and for logging. That was a big problem here with logging the data and synchronizing it with the 4 or 5 GPS that we had on the UAV. All this data here, we use it as an input to this air pollution model here that puts together all many aspects of the many physiological aspects here. We have a submodel that analyzes the resistances, the exchanges between the gases and the tree crowns. We have an energy balance model that uses the input from the solarimeter that is mounted on the surface below of the UAV, and on another station on the ground. So we have the net radiation absorbed by the vegetation here. And all the other inputs, vegetation height, the crown width, species, all these parameters are used by this model to assess CO2 exchange with the atmosphere, and also ozone and particulate here. So what we really want to assess here is the service ecosystem offered by the vegetation. And we use the UAV just for calibration purposes and for validation purposes. You can find a reference to this WebGIS that is an alpha model of an alpha version of this model. Here you can use it on the internet, you can play with it, and we intend to finish this model in about 3 months for project restrictions. Okay.
So, any question? Please.
What was the function of micro-radar? Just to keep the distance constant? Or?
A rapid assessment of the tree height, because one of the most relevant inputs of this model.
We have another question, please?
Yeah, you have different sensors on board on the UAV. How do the propellers making a movement of Earth, making some travels for the instruments? How
Yeah.
do you
This
try
is a really good question, because there is trouble, and obviously there is trouble. We are assessing here when during the flight of the UAV we have the less trouble, in this case, to catch the most, to reduce as much as possible here the noise. Obviously, there is a word behind the realization of these prototypes, with many prototypes that catch here gases from distance with pipes. Yeah, but here in these first experiments were mostly targeted to find the right mix of sensors, because we had many problems here with the resolution and accuracy of these sensors, because to study here the horizontal distribution or the vertical distribution of the gases, we needed a temporal resolution and an accuracy and a very high accuracy of these sensors. So we are still in this stage to resolve this kind of technical problem.
But you are online with these sensors, or you collect the data on the phone?
We are not online. We collected we just launched an Arduino routine, so we catch the data once we have it on the ground. But we are thinking about some Bluetooth technology.
Wi-Fi?
Or Wi-Fi, yeah, sure.